Welcome to our comprehensive overview of IBM Guardium Architecture. In this video, we'll explore how Guardium secures data across diverse environments, from on-premises databases to cloud platforms and hybrid multi-cloud setups. We'll break down the core components, monitoring methods, and management functions that make Guardium a robust solution for enterprise data protection. Whether you're new to Guardium or looking to deepen your understanding, this journey will clarify how Guardium fits into modern IT infrastructures and why it's trusted by organizations worldwide. Before we dive into the technical details, let's outline our objectives for this session. First, we'll define the types of data sources Guardium can monitor both actively and passively. Next, we'll diagram the various methods Guardium uses to monitor database traffic, ensuring comprehensive coverage. Finally, we'll identify the essential functions of aggregation, central management, and load balancing within the Guardium ecosystem. These objectives will guide our exploration and help you understand the full scope of Guardium's capabilities. Guardium is designed to protect data wherever it resides, on-premises, in the cloud, or across hybrid multi-cloud environments. Its flexible architecture allows for centralized policy enforcement and management, whether deployed as hardware or software. Guardium supports a wide range of data sources, ensuring that sensitive information is monitored and protected regardless of its location. This adaptability is crucial for organizations managing complex, distributed data infrastructure. Guardium offers both active and passive monitoring options to suit different security needs. Active monitoring uses agents like STAP and ETAP for real-time oversight of data sources, capturing sensitive activities as they happen. Passive monitoring, on the other hand, leverages agentless solutions such as universal connectors and streaming APIs, ideal for environments where installing agents isn't feasible. This dual approach ensures that organizations can tailor their monitoring strategies to specific risk profiles and operational requirements. STAP is a lightweight agent designed for real-time monitoring of on-premises data sources. It works by copying database traffic and sending it to the Guardium collector for analysis. The STAP agent intercepts all communications between database clients and servers, ensuring that every request and response is scrutinized for security risks. This setup allows organizations to detect suspicious activities as they occur, providing a robust layer of protection for sensitive on-premises data. ETAP extends Guardium's real-time monitoring capabilities to cloud environments. As an agent-based proxy solution, ETAP captures and analyzes database traffic in the cloud, ensuring that sensitive data remains protected even outside traditional data centers. For sources that are less sensitive or inherently safer, agentless monitoring can be used, offering flexibility without compromising security. ETAP is particularly valuable for organizations embracing cloud-first strategies. For environments where agents are not practical, Guardium offers universal connectors and streaming APIs. These agentless solutions provide passive monitoring for both cloud and on-premises data sources. Universal connectors can be tailored to a wide range of data sources, including popular platforms like MongoDB, MySQL, and Amazon S3. Streaming APIs further enhance monitoring by enabling seamless integration with cloud-native data flows, ensuring comprehensive visibility without the need for direct agent installation. STAP architecture is designed to ensure minimal impact on database performance while providing comprehensive monitoring. The STAP agent copies traffic to the Guardium collector, where resource-intensive processing occurs. The sniffer component can send control signals back to STAP, allowing for dynamic policy enforcement. This architecture ensures that all database communications are intercepted and analyzed, while the database server remains responsive and efficient. A typical Guardium deployment, the database client requests information from the server, but all communications are intercepted by the STAP agent. The agent ensures that every request and response is logged and analyzed, providing a detailed audit trail. This setup is crucial for compliance and forensic investigations, as it captures the full context of database interactions without disrupting normal operations. Guardium's monitoring capabilities are further enhanced by KTAP and ATAP modules. KTAP operates at the kernel level, hooking into client-server communications and monitoring the DBMS network port. ATAP, on the other hand, monitors communication at the application level and is dependent on KTAP. Together, these modules provide layered monitoring, ensuring that both network and application-level activities are captured for analysis. Certain database platforms like DB2, Guardium offers specialized integration through the DB2 exit module. This module is installed directly on the DBMS and requires minimal configuration. It leverages shared memory and network layers to capture and analyze database activity efficiently. This approach ensures that Guardium can adapt to the unique characteristics of different database systems while maintaining consistent monitoring standards. Some scenarios, external STAPs are used to monitor database activity from outside the primary server environment. These external taps can capture user activity, load balancing, and service interactions, providing additional visibility into database usage patterns. This is particularly useful for environments with complex network topologies or where direct agent installation is not possible. Guardium is fully compatible with modern containerized environments, including Docker and Kubernetes. When STAP cannot be installed directly, ETAP hosts can be auto-deployed and scaled within container platforms. Guardium is certified on Docker and Red Hat OpenShift, ensuring seamless integration with DevOps workflows and cloud-native applications. This flexibility allows organizations to maintain security even as they adopt cutting-edge deployment model. Universal connectors play a vital role in Guardium's architecture by identifying, parsing, and converting events from a wide range of data sources into a standard Guardium format. This enables consistent analysis and reporting, regardless of the underlying technology. Universal connectors support popular platforms such as MongoDB, MySQL, and Amazon S3, and can be extended with plugins to accommodate additional sources. This adaptability ensures that Guardium remains relevant as data ecosystems evolve. Guardium's architecture includes robust load balancing and failover capabilities. Universal connectors and collectors can distribute workloads dynamically, ensuring high availability and optimal performance. If a collector becomes overloaded or unavailable, traffic is automatically rerouted to maintain continuous monitoring. This design minimizes downtime and ensures that security coverage remains uninterrupted, even during infrastructure changes or failures. Guardium's user interface is designed for both ease of use and powerful automation. Administrators can define data sources, populate Guardium groups, and set up inspection engines through intuitive UI functions. Many of these tasks can also be automated via APIs, streamlining deployment and configuration. This approach reduces manual effort, accelerates onboarding, and ensures that security policies are consistently applied across the organization. Guardium integrates seamlessly with a variety of external systems, including SIEM platforms like Curadar and Splunk, cloud services such as AWS and Azure, and enterprise tools like ServiceNow and LDAP. This integration enables organizations to leverage existing IT investments, enhance incident response, and streamline compliance reporting. Guardium's open architecture ensures that it can adapt to diverse enterprise ecosystem. Guardium offers multiple monitoring options to address different security requirements. Agent-based monitoring provides deep, real-time visibility into database activity, while proxy-based solutions offer a lightweight alternative with minimal impact on performance. Agentless monitoring, using native audit logs and universal connectors, is ideal for environments where direct agent installation is not possible. This range of options allows organizations to tailor their monitoring strategies to specific needs. Agent-based monitoring, Guardium deploys lightweight probes that copy database traffic for analysis. These agents capture detailed session information, including who or what is accessing the database, what data is being requested, and any errors or exceptions that occur. The design ensures minimal impact on database performance, making it suitable for high-transaction environments where real-time oversight is critical. Agent proxy monitoring uses lightweight proxies to duplicate database traffic for analysis. This approach captures session and request details without impacting the database server directly. Policies control agent behavior, ensuring that only relevant data is collected. Agent proxy monitoring is especially useful in environments where direct agent installation is not possible or where minimizing server impact is a priority. Sniffer component is central to both agent and proxy-based monitoring. It decodes raw traffic, organizes sessions, normalizes activity, and writes processed data to disk according to defined policies. The sniffer also extracts and breaks down SQL statements, applying policy rules to determine what information should be collected. This granular approach ensures that only relevant activity is logged, optimizing storage and analysis. Agentless monitoring leverages universal connectors to capture and analyze audit logs from both cloud and on-premises databases. Logs are either pushed to storage by the database or pulled by Guardium, then transformed into universal format for analysis. While this method can impact database performance and storage requirements, it provides a flexible solution for environments where agents are not feasible. Agentless setups, the sniffer organizes received log data, applies policy rules, and normalizes activity before writing it to disk or sending it to an ingestion pipeline. SQL statements are broken down into their components, such as command, object, verb, and field. This structured approach ensures that even agentless monitoring provides detailed, actionable insights into database activity. Universal Connector Framework allows Guardium to support a wide variety of data sources through input and output plugins. These plugins filter, parse, and convert data into formats that Guardium can analyze. Policy correlation plugins further enhance this process by applying security rules to incoming data. This modular framework ensures that Guardium can adapt to new technologies and data sources as they emerge. Guardium uses aggregators and central managers to consolidate and manage audit data from multiple collectors. Aggregators serve as central repositories, storing filtered and summarized data for enterprise-wide auditing. Central managers oversee the status of collectors and aggregators, manage security policies, and coordinate reporting. This centralized approach streamlines compliance and enhances visibility across the organization. Aggregators in Guardium are dedicated appliances that collect and store audit data from multiple collectors. They enable complex reporting without impacting the performance of individual collectors. Reports are generated from the aggregator, ensuring that collectors remain focused on monitoring and policy enforcement. This separation of duties enhances both performance and scalability. Central Manager in Guardium oversees the entire monitoring infrastructure. It manages collectors and aggregators, pushes unified security policies, and centralizes user roles, permissions, and groups. Centralized report and audit process definitions ensure consistency and simplify administration. This centralized control is essential for large organizations with complex data environment. Typical Guardium configuration includes multiple collectors managed by a central aggregator and manager. Collectors monitor different data sources, while the aggregator consolidates audit data for enterprise-wide analysis. The central manager coordinates policy enforcement and reporting, ensuring that security standards are maintained across all monitored environments. In another configuration, aggregators can be dedicated to specific business units such as sales or human resources. Each aggregator collects data from relevant collectors, enabling tailored reporting and compliance for different departments. The central manager still oversees the entire setup, ensuring that organizational policies are consistently applied. More complex configuration might involve multiple aggregators and collectors assigned to different business functions. For example, sales and HR databases each have dedicated collectors and aggregators, all managed by a central manager. This structure supports granular control and reporting, making it easier to meet regulatory requirements and internal audit needs. Guardium's central manager enables dynamic load balancing across the monitoring infrastructure. By evaluating collector loads before assigning new STAP agents, the system ensures optimal resource utilization. Failover units can be defined as part of post-installation configuration, and STAP agents can be relocated automatically as needed. This automation reduces manual intervention and enhances system resilience. Load map and change tracker features in Guardium provide real-time visibility into collector workloads. Periodic full load collections and change tracking allow administrators to identify overloaded or vacant units, enabling proactive management. This visibility is essential for maintaining performance and ensuring that monitoring coverage remains uninterrupted. Now that we've covered the core components and configurations of Guardium, it's important to test your understanding. Reviewing key concepts such as data source monitoring, aggregation, and load balancing will help reinforce your knowledge and prepare you for practical application. Remember, a solid grasp of these fundamentals is essential for effective data security management. Summarize: Guardium provides comprehensive data protection through active and passive monitoring, flexible deployment options, and centralized management. Its architecture supports a wide range of data sources, integrates with external systems, and offers robust aggregation and load balancing capabilities. By understanding these core elements, organizations can build a resilient data security framework that adapts to evolving threats and operational needs. IBM and the IBM logo are registered trademarks in many jurisdictions worldwide. Other product and service names mentioned may be trademarks of IBM or other companies. This video is provided as is, without any warranty, and IBM is not liable for any damages arising from its use. The scenarios and examples presented are fictional and intended for illustrative purposes only. Guardium's strength lies in its ability to protect data wherever it exists. Whether your data is on-premises, in the cloud, or spread across hybrid environments, Guardium provides the tools and flexibility needed to secure sensitive information. Its centralized management and policy enforcement ensure that security standards are maintained consistently, regardless of where your data resides. Guardium's policy enforcement engine allows organizations to define and implement security policies that govern data access and usage. Advanced analytics provide insights into database activity, helping to identify anomalies and potential threats. This combination of policy enforcement and analytics is key to proactive data security and compliance management. Automation is a core feature of Guardium, enabling rapid deployment and configuration of monitoring agents and policies. Through APIs and automated workflows, administrators can quickly set up inspection engines, integrate external systems, and manage policy updates. This reduces the time and effort required to maintain a secure data environment. Guardium's open architecture allows for seamless integration with third-party tools such as SIEMs, backup servers, and ticketing systems. This interoperability enhances incident response, streamlines operations, and ensures that security data is shared across the organization's IT ecosystem. By connecting with tools like QRadar, Splunk, and ServiceNow, Guardium becomes a central hub for data security intelligence. Guardium's detailed logging and reporting capabilities make it an invaluable tool for compliance and auditing. By capturing comprehensive records of database activity, Guardium helps organizations meet regulatory requirements and respond to audit requests efficiently. Its centralized reporting features simplify the process of demonstrating compliance to auditors and stakeholders. As organizations increasingly adopt hybrid and multi-cloud strategies, Guardium's flexible architecture ensures that data security keeps pace. Its ability to monitor and protect data across diverse environments makes it a future-proof solution. Whether your data is in a private data center, public cloud, or both, Guardium provides unified visibility and control. Guardium's plug-in architecture allows organizations to extend its capabilities to new data sources and technologies. By developing custom plugins, you can ensure that Guardium remains compatible with evolving IT landscapes. This extensibility is key to maintaining comprehensive security coverage as your organization grows and adopts new platforms. Guardium plays a critical role throughout the data lifecycle, from creation and storage to access and deletion. Its monitoring and policy enforcement capabilities ensure that data remains secure at every stage. By integrating with key management and backup systems, Guardium supports data governance and lifecycle management initiatives. Maximize the benefits of Guardium. Organizations should follow best practices such as regularly updating policies, monitoring for anomalies, and integrating with existing IT processes. Ongoing training and awareness are also essential to ensure that staff can effectively use Guardium's features. By adopting these practices, you can build a resilient and proactive data security posture. Thank you for joining us on this deep dive into IBM Guardium Architecture. We hope this overview has clarified how Guardium protects data, supports compliance, and adapts to modern IT environments. As you move forward, consider how Guardium can be integrated into your organization's security strategy to safeguard critical information and support business objectives.